Hello YouTube. In this video we're going to be discussing the real number system and how we can classify the different numbers that occur within the set of real numbers. We tend to like to put things into groups in different sciences, mathematical science included. So we're going to look at the set of real numbers today, and to begin with we're going to kind of partition it into, or at least kind of separate it into different sets of numbers that all have their own special characteristics. Starting with this, the real numbers, the very first thing I want us to notice here is this. Within the real numbers, we can simply put it this way. We have a rational or an irrational value. Okay, so we're going to start with what we mean by rational and irrational. But first, let's look at whole numbers and integers before we build those up. I suppose we'll look at those first. But we say whole numbers. What is a whole number? When you think about a whole number, this is the number that you probably thought of in elementary school, but it does start at 0, this set of numbers, and proceeds up 1, 2, 3, so on and so forth. And this little ellipsis here means that it goes on forever and ever. But whole numbers have the characteristic that they are, of course, whole numbers, and you'll notice that there are no negatives. I'm not going to say they're all positive because 0 is a neutral number, but we say they are non-negative values. Whereas if we take the next step up here to integers, what is an integer? Well, we notice that the set of integers contains all of the whole numbers. So if you're a whole number, you are actually an integer, but what makes the integer more expanded than a whole number is the fact that we do include the negatives here. So these would be also like dot, dot, dot. We'd have -3, -2, -1, and then of course all of these whole numbers on the inside. So integers and whole numbers, you say whole numbers are whole numbers. Integers are like whole numbers, except for they also include the negatives. So what's the deal with rational and irrational? Well, when you hear the word rational, the way we need to be thinking really is this. The root of this word here is ratio. And when we discuss ratios in math, it is a comparison. Okay. Also this, a ratio can be written as a fraction. So it can be written as a fraction. So when we discuss rational numbers, we're discussing numbers that can be written as fractions, okay? So these are numbers of the form p over q, where these numbers p and q are numbers that we just got done talking about. So any number, basically, that can be expressed as a fraction, where we have an integer over an integer, is considered a rational number. So you might notice here that the integers and whole numbers are sitting inside the rational numbers, but you're sitting here saying, but those aren't fractions. And what I want to point out is this. If I were to write the fraction, say 4 over 2, which in other words is an integer 4 over an integer 2, realize that this simplifies down into 2, which is itself a whole number. So for example, the number 2, we could have put it over 1 essentially, but we say all whole numbers are rational because they can be expressed as fractions. They can be put over a 1 or put over a different integer. Same thing with integers. They can all be written as fractions if we would put all these over 1. So we say any rational number is a number like a half or 3/4 that can be written as the ratio of two integers. And there is one thing that I want to mention about rational numbers before we move over to irrational numbers, and it's this. If we were to put, say, 4/2 into a calculator, we'd get 2.0. Or if we were to put, say, 2/4 into a calculator, which is a half, that's another rational number, we would get 0.5. We would get a decimal. You notice this decimal stops. What if we were to put in, say, 3/9, which is the same thing as a third? This would be 0.333 repeating. And so there's one very important characteristic of all rational numbers, and that is this. They have decimals that do one of two things. Okay, and we write this up here, but we say numbers terminate or end. So this decimal here, you'll notice that it's 0.5. It didn't go 0.5 and on forever and ever and ever. If a number is rational, then it either terminates or it repeats indefinitely. So we notice in the case of 1/3, which is entirely a ratio of two integers, it's rational. We could see that this repeats forever and ever and ever and ever and ever. And sometimes you get some interesting ratios like 1/7, for example. You know, if we took 1 divided by 7, you would get this thing here, but you notice 1,42857, 1,42857, 1,42857. It's going to repeat itself for good. So all rational numbers either repeat indefinitely or they terminate. So what is an irrational number? Okay, so by definition, we say an irrational number is not a rational number. It is anything that is considered to be not rational. So we say these are numbers that cannot be written as a ratio, p over q, where p and q are both integers. Okay, that has to be the truth. So irrational numbers, we've got some famous ones here, but we say pi is an irrational number, or the square root of 2 is an irrational number. You'll notice that these things have one thing in common, is they go on forever and ever. And you might say, well, rational numbers, they do that, right? They repeat. But you'll notice that pi goes on forever and ever, or square root of 2 goes on forever and never, ever, ever repeats itself. Okay, it just comes up with a new string of digits. So here's what our job is this. I want to think about this. How can I possibly classify, say, this list of numbers right here and put them into their groups? I want to know, what does each of these numbers fall into, which category up here? And so that's what we're going to do before we end this video. Think about how we could do this in terms of strategies. You might pause the video and give it a shot. But I'm going to go ahead and kick this off. The first thing I notice is this, and this is kind of a lame thing, but notice 293. Obviously, we probably suspected 293 is a whole number up here. You know, it's on this list of 0, 1, 2, 3, so on and so forth. But the first thing I want to ask myself is it rational or not? And you say, okay, well, is it rational or not? 293 is definitely rational because, look, we can put a 1 underneath it and we have a ratio. We say, well, if it's rational, is it also an integer? We'll work our way in here. Inwards here, but we say an integer. An integer is a whole number that could be positive or negative, and this is a whole number that's positive, so it's an integer. And then now I'll ask myself the question, is it also a whole number? And obviously it is a whole number. So now my next one here, I'm going to say, well, is this rational or not? This is what we refer to as a mixed number. It's got a whole part and a fractional part, but we could say negative 47 and 5/9 could be written entirely in terms of negative so many ninths, and we would get this by taking the 47 times the 9 here. So we'd say 47 times 9, and we would add on that 5, so we'd say plus 5, end up with 428. So we say 428 ninths. This is certainly a rational number. Is it also an integer? And what we know is this. Well, it doesn't come out to be kind of like a whole number, like a whole value. It's got this actual, extra fractional part on this. So this is simply a rational number, and we would leave it at that. So we started off with a whole number. We say this rational number, negative 47 and 5/9 belongs up here in the rational numbers. Okay, so 0.184. Now we notice we have a decimal here. What I do want to mention is this. 0.184 is read as 184 thousandths, which is the same thing as we can write this as a fraction as 184 over 1,000. We can always read this number and write it as a fraction, but since we can, then it must be rational. And also I notice this, it terminates. It terminated its decimals. So if it terminates, it must be a rational number. It has to be this way. We say, is it also an integer? Well, it's not even a whole value, so we say no. So this is just a rational. It's a rational. So we say 0.184. That goes up here, 0.184. Moving on, we say 6/3, definitely a ratio, so it's rational. 6/3 we also know reduces to 2. So 2 is an integer. That would be on the list of whole numbers, positive or negative. And it's also a whole number, so we say 2 right here. We actually already included it on our list. So we've got this one taken care of. Square root of 7. Now, what I want you to notice is this. This often happens with square roots, and not all of them. The square root of 9, of course, would be plus or minus 3, which are integers. But the square root of 7 is not a perfect square. So we would say that this is irrational. Square root values, like square root of 2, are irrational. So we say square root of 7. So that one's done. We say negative 0.42. You'll notice it has this repeating bar here. The moment I see repeating, I think this is a rational number. Remember, we're asking ourselves this question first, rational or not. So we say this is rational. We say, since it's rational, is it also an integer? No, this is not an integer. So we say negative 0.4, and then the 2 is the only thing that repeats. So pi is an irrational value. It goes on forever and ever, doesn't repeat. Negative 7 wholes. Okay, well, this is a ratio of 2 integers. We say it's also negative, so it's also an integer. Negative 7 is on this list here of integers, but it's not a whole number because whole numbers are only positive. So we say negative 7 is on this list here. Square root of 9. Now, notice I said square root of 9 earlier is plus or minus 3. Well, we'll just go ahead and call this negative 3, but if it's negative 3, we could say that, well, first of all, it's rational. Notice that I could write it as a ratio. As a decimal, it would be negative 3.0, so it terminates. It's also rational. We say, is it an integer? Well, negative 3 is an integer. We can see it right here. And then also, is it a whole number? And it's not a whole number. So we'd say negative 3 or negative square root of 9 would be in this integers list. And last but not least, we say 4 2/3, kind of like the negative 47 and 5/9 earlier. We say 4 2/3. Definitely it's rational because I can write it as a ratio. And it's not an integer or a whole number. But that's how you would classify numbers in the real number system. Cheers.